Self-destruct initiated. T-minus 10, 9.
Okay, this whole video is going to be about the attempt on decapping the poly-A tail on the Tumor CD70, as well as many foods that could possibly help out with this. So the first thing here is a protein called ELF4E or ELF4E. Okay, so ELF4E is short for eukaryotic initiation factor 4E, which is a protein that binds the 5-mRNA cap, or in other words, the M7G cap, and recruits it to the ribosome for translation. So what ELF4E does is that it binds and protects mRNAs from decapping and degradation, and tumors often maintain high ELF4E activity to shield oncogenic transcripts from ARE-mediated decay. So basically, so the ARE binds to the TTP in an attempt to trim the poly-A tail on the CD70, which would be a bad situation, which also what the tumor fears. But the tumor will try to protect against that, or what it fears, by upregulating and binding and maintaining high ELF4E activity and levels. Okay, so basically, where the oncogenic transcription usually happens is what the tumor protects or shields. So the tumor is shielding away or shielding proteins like TTP or DCP1/2, and those two that I just mentioned, TTP and DCP1/2, normally trigger degradation of or the trimming of the poly-A tail. So that's basically what the tumor is protecting or shielding against in the oncogenic transcription areas. Okay, so basically high ELF4E allows cancer cells to continue translating critical proteins even during nutrient or oxidative stress. So, but basically cancer cells, they use those proteins for their immune destabilizing functions, also CD70 ongoing, poly-A tail trimming prevention, all kinds of things that cancer cells use to survive. Okay, so there are some fruits here that could possibly help. For example, oranges, grapes, and apples, maybe also pears and peaches and mangoes. And those fruits, they actually partially reduce ELF4E activity, which is a good thing, therefore leading to less cap-dependent translation of oncogenes. Now, oncogenes are basically genes that help cancer cells metastasize and to survive. So those fruits, they also destabilize some tumor transcripts by interfering with protective complexes such as ELF4E, PABP, or 5-cap interactions, because they basically they cap the poly-A tail, and the caps protect the poly-A tail from trimming. Therefore, the poly-A tail persists or continues to elongate, and then the CD70 on the tumor continues its antagonizing suppression against CD27, which could eventually lead to T cells being exhausted once, especially at the chromatin DNA level. Once that state is reached, it's very difficult to bring back the T cells after they are exhausted. So it's better to avoid that situation in the first place by trimming the poly-A tail. But the tumors have the defense mechanisms to prevent the poly-A tail from trimming. So those fruits, they have a dual effect. Tumors lose some translational shielding, which is the capping the poly-A tail to stop it from trimming, while normal cells mostly are spared due to lower ELF4E reliance, which is like a whole nother rabbit hole. Okay, so a quick recap. Tumors, they shield with by using the ELF4E slash PABP. What they're shielding against is the degradation caused by AREs binding to TTP. And then also the DCP1 slash 2 is the very thing that helps with the decapping. So tumors shield against that. So also fruits help to aid against blocking or preventing tumors from having the poly-A tail because uh, vitamin C, polyphenols, and flavonoids in those fruits, they promote AU-rich mRNA decay, which is also what tumors try to protect. Okay, now I'm going to explain the effects of some of the foods and fruits I already mentioned on the poly-A or polymerase. So basically, what the polymerase does is that it stabilizes mRNA for translation, which is not a good thing because then that means that the mRNA enables the elongation and the protection of the poly-A tail. So the mRNA has to be degraded by the decapping itself with the use of DCP1, DCP2, which removes the 5 milli-inch cap after deadenylation. Okay, so some foods that are known for their effects on RNA and poly-A is well, as mentioned, oranges, grapes, apples, pears, peaches, watermelon, tomato. These can enhance RNA decay of AU-rich mRNAs. So basically, in other words, by decaying the AU-rich mRNAs, that allows the trimming of the poly-A tail because mRNAs prevents the trimming of the poly-A tail, and even mRNAs might even strengthen the poly-A tail's resistance against trimming, allowing CD70 to continue. Now, a food to possibly avoid could be cheese, because cheese is high in saturated fats. This can enhance mTORC1 signaling, which is a bad thing because mTORC1 allows the stabilization and the strengthening of the poly-A tails and growth promoting mRNAs. Because since cheese enhances mTORC1 promotes mRNAs, therefore mRNAs promotes the elongation and the trim resistance of the poly-A tail. Okay, the next one is what tumors will try to stop or prevent by secreting protease inhibitors so that the protease inhibitors do not cleave off the CD14. Because of protease fruits like papaya, kiwi, and pineapple, they cleave off the CD14 on the toll-like receptor 4, which is what the tumors try to stop with the protease inhibitors. Now, the tumor secretes protease inhibitors as is actually a defense mechanism to avoid immune attack because the tumor knows that if the pineapple, kiwi, or papaya cleaves the CD14 off the toll-like receptor 4, then that will accelerate poly-A tail deadenylation, or in other words, leading to the trimming of the poly-A tail. So since kiwi, papaya, and pineapple are protease fruits, tumors try to stop the cleaving action by secreting protease inhibitors to stop those protease fruits from cleaving CD14, hence the immune defense mechanism. Okay, so quick recap before I end the video. So, okay, poly-A tail addition, normally done by poly-A polymerase, stabilizing mRNA. Basically, the mRNA being stabilized leads to the resistance of poly-A tail being trimmed. Okay, so fruits high in vitamin C, such as oranges, grapes, apples, pears, peaches, enhances RNA decay of mRNAs. So by decaying the mRNAs, the poly-A tail becomes weaker and more susceptible to trimming, which is a good thing. So that's it for the video. Like, comment, share, subscribe, and I'll see you in the next video.